So please give a round of applause for Dirk. Check out the conference page for the hackathon. And then for our next speaker, who's really excited about this?
Ah, gelukkig.
Who really played this when they were a kid?
I was going to ask those questions, but we're saving time.
Just to cut some time. Okay. Barry worked for Sanoma as a consultant for ClickView and MBI in general, and is in his spare time building amazing stuff. So he's going to tell all about reverse engineering.
Yes.
Sierra AGI. Please give a round of applause for Barry.
All right, everyone, from hot new technology to old school 30-year-old stuff. So I'm Barry. See fewer and fewer familiar faces in the crowd nowadays, but most people that know me as that ClickView guy who walks around here. Since I started at Sanoma, my business has grown significantly, and we're also doing other things than Click. So, and this is one of them. No customers for it yet. So what am I going to talk about? I'm going to talk about the Sierra Online Adventure Game Interpreter. We'll look at an introduction, some games. Then we'll go through some interpreter specifications. So how does this actually work under the hood? And how do you do the game loop, parsing user input? And finally, I'll conclude with looking at some of the game resources, the images, sounds, sprites that are contained. So what is AGI? I actually saw more hands raised than I was expecting. AGI stands for Adventure Game Interpreter. It's an engine or interpreter for 3D games, as they were imagined back in the 80s. And the 3D aspect was that you could walk in front or behind a tree, those kind of things. It was initially created by a company called Sierra Online for a game called King's Quest, Quest for the Crown. And this was the launch title for the IBM PC Junior. Anyone ever seen one of those? Maybe in the museum? Well, the computer flopped, but the game became very popular and it spawned some more. You have one? Surfing the startpagina pages. Anyways, for those of you who don't know these kind of games, the mantra is save early, save often. That helped me in my development career as well. And it was really a revolutionary game at the time. Before you had text adventures, you could input some text, but it would just show you text on the screen. Then the next major innovation was showing a single picture. So you could just get a picture of what was going on, but here the player could walk around in 3D space. It's also frustratingly hard. And just open. Just show you, for those of you who've never seen the game. Well, we've barely started the video and the first death has already happened. So the idea is you can walk around and type in a command, for example, push rock. Seems sensible. No, this rock rolls downhill, so you're dead. Everything in this game kills you. Too close to the edge? Sorry, you're dead. This later inspired a sort of counter movement for adventure games where you couldn't die and you could always finish the game. The Lucasfilm games, I'm sure many of you know those as well. So games and platforms, the interpreter. This interpreter was used for 14 games between 1984 and 1989. 4 King's Quest games, Space Quest, Larry, Police Quest, and ended with the Manhunter games where they added even a sort of rudimentary point and click. Who's actually played these games?
Have we seen Quest for Glory?
Quest for Glory is not an AGI game.
Oh, okay.
It's an SCI game. That's the interpreter that comes after this. I'll be doing it next. So they made 3 versions, and I've mainly looked at versions 2 and 3 because first games from version 1 were eventually re-released. And it was ported to a lot of different platforms. So the PC, the Apple II, Macintosh, Amiga, and Atari ST. I mainly focused on the PC, and the development took mainly place on the PC, but they are available in different versions. So you may be wondering, why? Why not? Exactly. For me, and I think you need to fit into a certain age group, but for me these games really got me interested in computers and programming, and also taught me a fair amount of English. And look, here we are again. I just wanted to know how they work. I tried at the time building similar games in BASIC and whatever with shitload of go-to statements, and now that I've grown a little bit, I think I know better coding practices. And I actually learned lots of new things along the way, not just about debugging, but dealing with binary data, compression, encryption algorithms. So it's a sort of archaeology, digital archaeology, and quite interesting as well. At least I think so. So the AGI files, as I mentioned, the interpreter is platform specific, so you can get an interpreter for the Amiga, for the Atari ST. But all the resources are platform independent, so all the pictures and etc. And these are generally log dir, view dir, pick dir, sound dir, so the game logic, the game sprites, the game backgrounds, and the game sounds. And that's the dir files are like an index of where can you find all this data. Then you have volume files that actually store that data. You have words.toc, which is the actual words that you can use in the game that the interpreter knows. You have objects that are the in-game objects. So I thought it was a pretty nice setup how they did it. And of course, if you played the game back in the day, you probably recognize these files from the directory listings as well. So the interpreter specifications, well, this is not very high tech. I think that light bulb we just saw has more than enough power to run these games. In the interpreter you have 265 8-bit variables that you can set, unsigned integers, 265 Boolean flags that you can set, so is this in possession or not. You have a few objects, and those are not inventory items but sprites that can be controlled by the interpreter. And the first one is always the player, which is referred to as the ego. You have inventory items, and you can store 12 to 24, depending on the version of the interpreter, 40 character string variables. So not a whole lot. They really did a lot in a very limited space, I think.
This is per screen or per game?
No, it's per game.
Well.
Yeah. So how does the interpreter work? Well, basically like any game, it runs in a constant loop. There's a wait time. It starts with a wait time. You used to have like fastest, fast, normal, slow. That determines how long it waits. It empties your keyboard buffer, so whatever you put in, or what was in from the previous loop. Then it gets the new keyword input. It checks a few internal variables and flags, about which I could talk another hour, so skip. Then it redraws all the sprites on the screen, and then it starts executing the logic. And the logic, what happens in each room, is stored in logic resources. The first one is always the main program that shows you the menu and stuff. And then every room has its own logic that is contained. And then it checks if there's a new room. If we moved, did you go through a door? Then it tears down the current room and moves into the next room. So user input, how's that parsed? First it removes all the punctuation marks, convert everything to lowercase, replace all the spaces, multiple spaces, with a single space, and then it checks each word against the vocabulary. This is an example that I remember as probably 9 years old, playing Police Quest 1. Not sure if has anyone played this game? Good. There is this scene where in Police Quest you play a police officer, you have to arrest people and solve crimes and stuff. There's this scene where you pull over a drunk driver, and he's obviously drunk, but you have to test him for sobriety, if he's drunk. So as a 9-year-old non-native speaker, I was like, do test, all sorts of things like, what can I do to test? Oh. Well, it turned out, at least the answer I found was perform test. That worked after like days and days of typing it in. But the idea is here there's an action that's called action 80, which is something like do, and all these synonyms will work for it. And it's actually in some of the search functions that I use in my projects have the same thing with synonyms where you replace one word for another. So it was kind of smart. So an example of the logic would be if set administer and test, then it does something. There's also a placeholder for any word, so if there's any word it will just say okay, and that's how part of the logic works. It's not object oriented, and on this talk I won't go more into the logic because I'm still figuring a lot of it out myself. But words.toc encoding, found that very interesting. Those are all the words that you can use in the game, and if that's plain text, then it encourages cheating. So it's sort of encrypted. It starts with 26 times 2 bytes with an offset in the file for each word. And then the individual words are very interestingly stored. It first says what is the number of characters from the previous word that you want to use, and then gives you individual characters to append, and these were encoded with XOR 127, and then it ends with the word number. So it's quite a puzzle to figure it out. So if the previous here and then the current word is best, it would just say 2ST and then whatever word number there is. I'm not sure why they did this, because this is generally the smallest file and they don't use this anywhere else, but it's interesting.
And you figured this out, or you saw somewhere how they do this?
So with reverse engineering, I initially started with DOSBox and IDA plugin. Then that wasn't really quite working for me, so I moved to a DOS machine and SoftIce. And then I got so far, I thought, well, then I started to Google. Should have said, hey Google. And then I found a lot of documentation. A lot of these things have already been figured out. So I did treat it as a challenge, like normally you would with the games. You try first yourself, and then if after 1 day or 2 days it doesn't work, you look at the walkthrough. That's basically how I approach this project as well. So some of the other resource types: logic, game logic, pick, game backgrounds, view, game graph, sprites. I was confused the two. I would say pick is sprites and view is background. Sounds. These are stored in the vol files and indexed in the dir files. I'll talk about these going bottom up. So dir files describe the location of each asset or resource in the game. So there are separate files for the version 2 and one file for version 3, and they're just stored in 3-byte iterations. The first 4-bit contain like what file. There may be 4 or 5 volume files. So the first 4-bit will tell you which file, and the next 12 bits will say what's the offset. So you might read 1061A8, and in binary that works out to this. So the first bit on the side there is volume 1, offset is 25,000. And then you know to look for a particular resource in that file at that location. So for example, you can't quite see this. So this is sound, so it will say the first sound is in volume 1 at this offset, the second one is there, and then the fourth one is, and the third one are in a different file, but sequentially they are sounds. I just dump all this stuff to JSON because it's much easier to work with, do most of this in Python. So the volume files, they contain the actual game stuff. Well, briefly go through this. For some reason it always starts with 1, 2, 3, 4. It's the signature. Then it says the volume number. You can see in the file as well, that's called vol.1, but it will still store 1. And then the length of the resource. how long is this file, and also if they applied compression, which some of the later interpreters did, it will tell you what's the compressed size and the uncompressed size. And how it's stored depends on the resource type. So the view resource, and view are the game sprites. There's a hierarchy there. They are first called views, and these contain loops, and each loop contains cells. And some of the loops may be mirrors of other loops. So just to show you, this is Space Quest 1. It's view 0, and it just has 4 loops. And the second one is just a copy of the first one. 5 minutes? Could miss out on all the good stuff. And of course, if you put them all together, you can animate them. So the header encoding, first one, couldn't figure it out. Doesn't matter. So each, how do you say it? Each view has a number of loops. So it shows you the number of loops. It shows you the position of the description, if it's an inventory item, position of first loop, second loop, etc. As I said, loops at point. So they have some compression going on there, or just saying mirror this sprite for it to go the other way. Then you get down to the loop level, the number of cells. Then it shows you the position of the first cell, then the position of the second cell. So once you're extracting this, you can imagine that you're doing quite a bit of seeking through the file, picking it up from various positions. So then you get to the individual pictures, and that gives you how wide is the cell, how high is it, so how big and wide is the picture, and then it gives you mirroring and transparency. So the first 4 bits will tell you, do I need to mirror this image? And the second bit tells you what's the transparency color. Every sprite has a transparent color. The interesting thing when I first started drawing these things that I was getting from there is that they were really narrow. And it turns out to be that every pixel they use in the AGI is actually should be drawn as 2 pixels wide. So that's, you can see it maybe here as well, that there's no step with a single pixel. So that's why it looked crap. Only that because. So this is an example, it's JSON. I have the GitHub project, so you can look it up if you want it. So the cell data. So once you have figured out what loops are there, what views are there, how many loops are in there, how many cells are in there, and then you start decoding the individual cells. Well, they are stored as a bitmap using run length encoding. So 1 byte stores both the color and the number of pixels, and then each line ends with 0. So we might get A3C59200, and it will say A3, dead color of the palette for 3 pixels, 12, 5 pixels, color 9, 2 pixels, and go to the next line. And that's how it will draw. So there's no bitmap, it just stores if it's repeating pixels, and most of the time that works nice. The version 3 uses LZW compression, but you can also talk a full hour about that. Skip it for now. So those were the sprites, the things that are moving in the game. So the PIC resources are store the actual game background images, and the resolution is 120 by 168. It's 2 pixels, so that gets blown up to 320. And if you remember, the resolution was 320 by 200. Nothing ever gets drawn under the 168. That's where the interpreter, the input box goes. Question for you, looking at this picture, what do you think? Is this a vector or a bitmap?
Bitmap.
You would think it's a bitmap, right? But it's actually a vector. So the background images are not stored as individual bitmaps, but just as points going from one way to the other. And that's because at the time they didn't really have very good input devices to draw bitmaps, and it stores a smaller file size as well. So they got one of these, they made their drawing and then traced it, and the computer just stored the commands. And then the fun thing is that if you play it back slowly, you can actually see in the game data how the artist originally drew the whole scene. So this is just the artist steps are being replaced. So this is 30-year-old drawing. Anyone know which game this is? Larry, yes, it's the opening scene from Larry. So you have 36 seconds, so it goes on. You can see it's now drawing all the individual. It must have been a lot of work. So storing them physically within the binary, within the volume file, it stores both actions and data. So when you process the data, any byte value equal to or greater than 240 is an action, and the rest is just data. And I won't go into all the different parameters because we've got 6 seconds. But you can change the color and enable the picture draw, change the color and enable priority draw. That's on the next slide. You can draw different corners where just say, okay, I only give the Y or the X and it moves a little bit, it saves some space. You can draw an absolute line, you can draw a relative line, so the last point. Full fill, that's very nice to implement as well. You can change brush, so you have a few like these paintbrush things that you can use, and you can plot with the brush. These are basically all. So the logic is looping through, getting is the value greater than 240, okay, so then we're in a specific mode, start processing the data until we hit another value above 240. So I mentioned priority screen, and this is also an interesting thing. Some of you played it back in the day may have seen the debugging screen where this is also shown. So every screen that's shown actually has 2 screens associated with it. The screen that the player sees and the priority screen that's also being drawn. And anyone know this game?
Space Quest. Yeah.
Space Quest 2. Do you know what happens? What do you know what happens here?
Sorry?
Do you know what happens here? If you walk across this line,
would grab you from above and try to eat you, I think.
Yeah. So this is like a line that if the player walks through this, it gets triggered. And the same here. If you walk here, you fall off the cliff, and there's loads of ways to die. And also it shows you how to draw the tree. So in this case, the lighter the color, the more to the front it is. So if the character is walking here, he will not walk across the tree, but behind the tree. So that's the way they use to achieve the 3D effect. It's actually, well, I'm already out of time, but there's also priority bands, and drawing these screens, they look very simplistic, but it's a real checkerboard that you need to draw, otherwise the player will, it will not look naturally. So actually everything here is arranged on really like a checkerboard, but it's arranged in such a way that you really don't notice, but that's what makes the 3D works. So where does it go from here? Well, onto a beer. And then what I currently do is what I showed you: export vocabulary, inventory items, sprites, backgrounds for all the games. Again, why not? So then I do what I always do with stupid projects: create a bot to randomly post it to Twitter, where the retro gaming community has certainly enjoyed it. And I did some prototyping to build my own interpreter. I start these projects to learn something, and this has been very educational on dealing with binary data, on dealing with, well, stuff in Python and working with JSON, etc. But I still want to find a convenient format to dump the logic and the sounds. I can export them now, but need to be able to interpret them correctly. And I want to build my own JavaScript interpreter because JavaScript entails a lot of my work nowadays. So I figured, well, it's a nice hobby project. And there's always, well, when I mention this, people always say, do you know Seri in .NET? Does anyone know Seri in .NET? No. You can play all these games online. Someone already did the whole JavaScript stuff, but I'm not looking at that. I'm just going to do my own thing. So that's it. Thanks for attending, and here's some of the stuff that all the code I have on GitHub and technical documentation. If you say I really want to relive the 80s, that's it. Thank you.
You guys start setting up a question for Barry.
Yes.
Are you working on your own game as well?
So the original idea for starting this was I had this 404 page, and I figured wouldn't it be nice if there was a little game there. Yeah. Then I figured, okay, what kind of game? Well, maybe an AGI game. Well, then I need to build it in JavaScript. Then I need to figure out how to get the resources. So it sort of all went from there. But yeah, eventually I will, yeah. And I built lots of little other games, but not adventure games in.
Is the copyright already?
No, the copyright is not expired. It's owned by Activision.
Okay.
So
Yeah. You control the rights of.
yeah,
If you don't post it, right?
they don't know who I am.
Did you
Get somebody money.
figure out all the? Can you figure out all the secrets from those files now? So you can parse the logic files, and you can see. You can open up the logic file and see what happens on the screen.
Yeah, you can see. So what it is, it gets sort of compiled, so where the original programmer would see if he said give breathalyzer test, something like that, it will just say, well, if it's a command number 5, 7, 8, but you know, okay, this is if, that's set, and that's, so you can figure it out. Yeah.
I think they're only pre-printed and recognized.
Yeah.
Did you give you a round of applause?
No.
Entire new generation.
And otherwise, I think you also deserve 2 rounds of applause. That's no problem. And it's really funny that you're like the pre-show to Attila, because you know he made one of the 80s games himself and sold it.
Oh really?
Yeah, it was a